Hello and welcome back. Today we're looking at January 7th, Exploring Systems Part 2. So today we are going to continue our activity exploring systems of equations. But before we do too much of that, let's look at the discussion about systems of equations based on the work we did on Tuesday. So if this is a picture, I could have an equation 1, and the solution to equation 1 could be this red line. The solution to an equation always just looks like a line. So equation 1, and I have equation 2. If these are two equations that are related to each other, then this graph, then they are a system of equations, and this graph would represent a system of equations. The red line is a solution to equation 1, the blue line is a solution to equation 2, and then there's this point right in the middle that I circled, because that's the point where those two lines cross. Now, what makes the red line the solution to equation 1 is the fact that any point on that line makes the equation true. Any point on the blue line makes the blue equation true. But this point where they cross is special. It's very important. This is the only point. It's the only point on the whole graph where both equations are true. The point where they intersect is the place where both lines have the same values, so both equations are true. And that is what we call the solution to a system of equations. Right? If the solution is a place where the points make the line true, that's the solution to an equation, then the solution to a system is the place where all lines are true at the same time. So pictorially, this is a system of equations and an identification of what the solution is. If we want to put that in words, right, the solution to a system of equations, should be equations plural, I don't know if I can change it. The solution to a system of equations is the x and y values that make both equations true. And I'm going to add here at the same time, right? At the same time. So it's going to look like x comma y. It's some xy value that makes both equations true at the same time. And again, looking at the picture, it's this point where the lines cross. So I can just add a note here on a graph. It's where the lines cross. Okay. And then the rest of the discussion questions really kind of center around, well, what possibilities do we have? If we have a system of two linear equations, there are three possible outcomes. So if you remember in day 1 of exploration of systems, you had to make 3 graphs. So the first one was where the lines intersect. So the first possible outcome for two linear equations is that the lines cross. And in this case, there is one solution to that system of linear equations. The one solution at the point where those lines cross. The second possibility is that the lines are parallel. They never cross. And in this case, if they never cross, there is never a point where both equations are true at the same time. So there's no solution to the system. It's not possible to solve that system of equations. There's just no solution to it. And then the third possibility is the place where the lines overlap, right? And in that case, you probably discovered that really it turns out they're the same equation written a different way. Okay? Well, if they're the same equation written a different way, so that they completely overlap each other, they run completely on top of each other, well then any point in the line is going to be true for both lines, so there actually are infinite solutions to that equation. So those are the 3 possible outcomes that we can have for a system of 2 linear equations. Okay? So with that discussion behind us, let's go back to the new assignment for the day, which is this Exploring Systems of Equations Part 2, and review our learning goals. We wanted to define a system of linear equations and what the solution to a system of linear equations might look like. We wanted to be able to identify how many solutions does this system of linear equations have? One, none, infinite, right? And then our last step was we wanted to be able to create a rule that could tell us, just looking at the equation based on the slope of the lines, how many solutions is this system of equations going to have? So today we're really focusing on that third part. Okay. So we're using the same tool that we've been using the last couple of days, this PhET simulator. And remember, when you log into the link, you want to make sure you choose the second box, the slope-intercept form, because all of our equations are in slope-intercept form. So we're going to use that same tool, and this time they're giving us the equations that they want us to graph. So for each row on this table, graph the system of equations on a clean coordinate plane. So I want to graph y equals 2/3 x plus 3. So I would just go and I want to adjust these numbers until they look like 2/3 x plus 3. So you can see that here. You can see the equation written right here, y equals 2/3 x plus 3. Then I would save that line and then go back and look at this next one, 4/6 x minus 5. So I would want to make a new line, minus 5, change this to 4, 6. Okay, now I have these lines. I can go ahead and paste it here and decide, does this system of equations shown have one solution, no solutions, or infinite solutions? So once I find that out, I can check it. If it has one solution, tell me what that solution is. Otherwise, just check, hey, there's no solution, or there's infinitely many solutions. So for 1, and then continuing down 2 and 3, I want you to just follow those same steps, make the graphs, and tell me what you conclude from that. Here is a hint that I put in. Sometimes, right, where you see like 18/6, sometimes look and see, hey, can I simplify this equation before I put it in? Are there any numbers here that I can simplify before I even put them into the tool? So the first 3 are just giving the systems of equations that they gave us, graph them, look at them, and tell me how many solutions are there. Then there's another set of 3, and these ones I want you to try without graphing. Don't use the PhET tool for these. We're going to start making our own rule so we can just look at it. If I look at these equations and I think about what they're going to look like, is this system of equations going to have one solution, no solution, or infinite solutions? And I will pick this. In this case, you don't have to tell me what the solution is because you don't know how to do that yet. That's our next step. We're going to learn how to solve without using a graph. But for today, you just have to pick which one it has, and then go ahead and just in a short sentence tell me, I know that there's going to be one solution because. I know that there's going to be no solutions because. What is the reason that you're thinking that tells you how many solutions there's going to be? And then using all this information and the conversation we had in the class discussion, go ahead and fill in this rule, this graphic organizer to summarize what we've learned about solving systems by graphing. And you're just going to have to get a text box out and fill these in. What is true about the slopes and y-intercepts of the equations when there is one solution? I do want you to fill in all parts of this, but I have been pointing out to students that for the last 3 days, we've been looking at systems of equations. So you have a whole bunch of examples of systems of equations, and it is totally okay to go back and use an example from somewhere else in the assignment if you don't want to make up your own new sample. But you need to go ahead and fill this in. If there's one solution, I know the y-intercepts and the slopes are going to be something, and the graph looks like, just fill this in for me. When you're done with that, there is an exit ticket, just kind of summarizing this whole activity we did. It asks some of the same questions, but just take a minute to fill this out. Use complete sentences to describe your thoughts, please. Okay? So the first question, describe what a system of linear equations is and what is its solution. Right? a system of linear equations is, the solution to a system of linear equations is, just fill that out. How can you determine whether a system of linear equations has one solution, no solutions, or infinitely many? By looking at the graph. What will you see on the graph? And then, how can you determine whether a system of linear equations has one solution, no solution, or infinitely many solutions? By looking at the equations. So just use complete sentences to fill this in, just summarizing what you've learned and discovered through this exploration. So if you have any questions, please let me know. And that's all there is.